Greetings, M squared here. We're going to talk about rationalizing the denominator. This is like a level 1. In the bottom we only have one term. Keep in mind your 3 rules of simplifying radicals. Number 1, no perfect squares under the radical, or if you're talking about cubes, no perfect cubes. Number 2 is no fractions under the radical, kind of like this one. And number 3 is you cannot have square roots or radicals in the denominator. So we are going to take care of that rule today. So what we do here is the only rule we're breaking is that radicals in the denominator. I call it rats in the basement. So to get rid of them, we just move them upstairs, and then we can see them and we take care of them. Just kidding. Okay, so to get rid of square root, to get rid of the radical, we do the opposite, which means we need two factors, or the square of that, when it's a square root, to get rid of it. So we actually multiply by the square root of 5 times over the square root of 5. Now keep in mind, this is the number 1. When I multiply something by 1, it stays the same. So I'm not changing the value, I'm just changing how it looks so that I no longer have square roots in the bottom. And when I do that, remember, outside times outside, inside times inside. So in the top, I get 4 square roots of 5. And in the bottom, you can do it 2 ways. You can say, oh, that's the square root of 25, which is 5. Or you can remember that anytime I take the square root of a number times the square root of the same number, I just get the number. They kind of cancel out. I'm not sure which way you like to do it, but you can either do square root of 25 and then change it to a 5, or just remember that it's a 5. And then they're no longer in the denominator. It's okay to have them in the numerator, so I'm done rationalizing that denominator. On to this one. This one, you could, some people just automatically multiply by whatever's there. I like to simplify it first. I don't really need to multiply by 7, because 7's not the problem. The square root is the problem here. But if I can cancel, I like to do that first. Because the rule says, one of the rules of the properties, and if you need to go back and look at that, go ahead and do that, the section on properties of radicals. I can change 2 things that are being divided to one thing, a fraction that's under the radical. And the reason I did this is to show you that I can cancel. 5/15 is the same as 1/3. So now I have 3 times the square root of 1, which is just 3, over 7 radical 3. And then all I need to do is get rid of the radical 3. So again, I multiply by the square root of 3 over the square root of 3, which is 1. And in the top, I get 3 square roots of 3. And in the bottom, I get 7 times 3. Now, the reason I didn't multiply that through, I could have, because the square root of 3 times the square root of 3 is 3, is because I know that there's a 3 up there. I kind of planned ahead, and I said, well, I'm going to be able to cancel. So instead of writing 3 radical 3 over 21 and then reducing, I just do like that. It either way works. So my final answer for this one is the square root of 3 over 7. And notice, no square roots in the denominator. Okay, on to this one. This is one fraction. I can't cancel anything. X and Y don't cancel. So the first thing I do is split it up into 2 square roots. And then I ask myself, is there anything that I can pull out of here? The first rule of simplifying radicals is the perfect square. So yeah, that's a 4 times a 3, and that's a y squared times a y. So I split that up, and I get the square root of 7x over the square root of 4 is 2. The square root of y squared is y, and then inside I have a 3y, because these two don't have perfect squares. And then I realize that I only need to get rid of this part. So I'm going to multiply by the square root of 3y over the square root of 3y. So inside times inside, so in the top I have 21xy, in the bottom I have 2y times 3y, because the square root of 3y times the square root of 3y is 3y. So I need to simplify that a little bit, but the top stays the same. And I get y squared. Notice that this is outside a radical, this is inside a radical. I cannot cancel things that one inside and one outside. So this is the answer. And I could have written that neater. There we go. Okay, on to this one. Notice it's a cubed root, so we do that a little bit different. We're going to first split it up like we did the others. And then what I need you to notice here is that in cubed roots, you have to have 3 of the same factor. So I do not want to multiply by the cubed root of 9x squared, because that won't get me something that I can take the cubed root of. So I have to kind of see, I have 2 3s here. How many would I need to pull one out? Well, this tells me right here, this index. So I need one more 3. I have 2 x's, so I need one more x. So that's the tricky part about the cubed roots or fourth roots. You have to make sure you have the number of factors that the index indicates. So when I multiply on top, inside times inside again, so I have the cubed root of 15x. And on the bottom, I have the cubed root. 9 times 3 is 27. X squared times x is x cubed. And I'm showing work here so you can see what I'm doing. Because on the other ones, I didn't show this as much. The cubed root of 27 is 3. The cubed root of x cubed is x. So now I don't have any square roots, cubed roots in the denominator, no radicals, and I'm done. And again, I cannot cancel these because this is on the inside of a radical. This is on the outside of a radical. So that would be my final answer. So it's a little bit tricky. If you go slow, you'll get it. Good luck with that. M squared.